Okay, let's have a look at percentage composition of compounds. Let's take the population of the world, and we can see that the composition of females in the world is about 51%, and the composition of males is about 49%. Now we can do the same thing, finding this percentage composition, by mass in compounds. So if we took water as a compound, by mass, there's about 11% of it is hydrogen, and about 89% of it is oxygen. So our percentage composition of a compound is defined as the mass percent of each element in that compound. So as we said before, by mass, hydrogen is about 11%, oxygen is about 89% in water. Now there are two ways to calculate this percentage composition. First of all, we can use the chemical formula, and the second way to do it is experimentally. And we're going to look at two examples that show us both of these methods. So first of all, calculating percentage composition from a formula. The first step is we need to calculate the molar mass for the compound in question. And the second step is to divide the total mass of each element by the molar mass for the compound. And we multiply this by 100 to give us our percent. So writing our formula out, percentage composition of each element is equal to the total mass for an individual element divided by the molar mass for the whole compound multiplied by our 100 to give us our percentage. Let's look at this in the process. If we're to calculate the percentage composition of potassium chloride, as we said, the first step is to calculate our molar mass. In this case, our molar mass of potassium will be 39.10 grams. Our molar mass of our chlorine will be 35.45 grams, giving us a total molar mass for our potassium chloride of 74.55 grams. So that's our first step done. Our second step, we're going to look at the percentage composition of our potassium and our chlorine. And to do that, we use our molar mass for our potassium and divide it by our total molar mass for our potassium chloride. Now our units cancel out, so we're left with 0.5245, which if we convert to a percentage is 52.45%. We do this once again with our chlorine, 35.45 grams from our molar mass for our chlorine by our total molar mass for our potassium chloride gives us 0.4755, and our units once again cancel out, so we're left with just 0.4755. We convert this to our percentage by multiplying by 100, and we've got 47.55. Now a good check mechanism is to determine whether our total percentage for our compound is 100%. So we add our two numbers together in this case, 52.45, 47.55, gives us 100%. And if we're doing this theoretical calculation from our formula, we should always end up with that 100%. Let's look at the second way of doing it, and that's calculating through experimentation. So let's say we added 1.63 grams of zinc or it combines with 0.4 grams of oxygen gas to form zinc oxide. And we want to calculate the percentage composition within that zinc oxide compound. Our first step is to calculate the mass of the compound formed. In a similar way to the previous example, we need that total mass, or that what we had was the molar mass before. This time we're just looking at the mass that's formed. Once we've got that, we divide that mass by the mass of each element, and once again we multiply by 100 to give us a percentage. So the first step to calculate our total mass, our mass of zinc is 1.63 grams, the mass of oxygen is 0.4 grams, which gives us a total of 2.03 grams. Our second step, we can then start calculating our percentage composition. So if we look at what we've done, we've got our mass of zinc, 1.63 grams, divided by our total mass that we calculated in part 1 to give us 0.803. Our units cancel out. If we multiply this through by 100, we get 80.3% for our zinc. So percentage composition of zinc in the zinc oxide is 80.3%. We do the same for our oxygen, 0.4 grams divided by the 2.03 gives us 0.2, And if we multiply this through by 100, we get 20%. Now once again we want to do a check, and we want to see that our individual components add up to 100%. So if we add the 80.3 and the 20 together, this time instead of getting the 100%, we get 100.3. Now that 0.3 is within experimental error. So our percentage composition for these two components will be somewhere around 80% and 20%.